Okay, so today we're going to talk about circuits in the most simplest form. That's why the title is Simple Circuits. So let's go ahead and jump in. So a circuit in general has three things. It has a source of a voltage or a voltage difference, which we talked about yesterday as a battery that applies the force that moves the current. There's a resistance device that will take in these electrons and it opposes the flow, which we want that to happen because we use things that can oppose flow, like a light bulb. And then there's a conductor, or something that moves electrons very easily so that it can go to these resistors or it can flow from this voltage difference. So, for example, this would be a really general drawing of a current, or a simple circuit, where you have a voltage difference, you have the conductor, this wire, and then you have some sort of resistor like a light bulb. And what this does is it creates something called a closed circuit and allows it so that the whole circuit is closed off. This right here would be closed, so it'd be almost like a door where you have this open right now, so current would not be able to flow through. This would be considered an open circuit. But if you can create a closed circuit, that's what allows us to turn this light bulb on and for electrons to move easily. There are two types of circuits that we're going to talk about, but even more generally, there's two ways we can talk about circuits and how they control electron movement. So there's one idea is called an open circuit, which has a break in the path that the current would normally travel in. So that means that if there's a break in the path, that means you're not allowed to travel. The electrons are not allowed to move. So no current travels at all. This is an example of this would be a light switch that's turned off. What it does is it creates an open circuit so that electrons cannot flow to that light bulb. And an example of that would be something along this line where you have this open area right here which makes the flow not complete, so it can't reach the light bulb. However, there's also obviously times when you want it to be closed, when you need light or you need that some sort of appliance to be turned on. So that's a closed circuit. It has a complete path. This would be closed, look like one black line for the current to travel through. And an example of that would be if the light switch was turned on, it creates a closed circuit. Now there's two different ways for us, for our understanding, that we can manipulate circuits. We can make them do different things. We can use them for different purposes. And the first one is called a series circuit. So a series circuit only has one loop to follow through. And it looks something like this down here. It's just a simple square where we have a voltage difference, we have a conductor, this wire, and then we have some resistors along one loop. So there's good things and there's bad things about series circuits. One, it's very simple to manufacture and to have, but if one of the light bulbs goes out or if one light does stop working, that means that the rest will go out because since it's in one loop, if the electrons stop right there, then they can't go anywhere. So it stops or it prevents the circuit from completing. And the amount of current is the same throughout all parts of the circuit. So there's not going to be one part that is at 10 milliamps and then another part's at 30 milliamps. It's going to have the same throughout. A good example of this would be flashlights or holiday lights, like this right here. And you guys have seen this before if you've ever been dealing with Christmas lights. And if one light bulb goes out, if you maybe have an older set, then that means the whole set will go out. Newer sets of holiday lights, most of them are going to be dealing with a different type of circuit, which we're getting ready to talk about. But still, some things use this series circuit. So we had series circuits, which a series just means a continuation of the same thing. So that's why you'd see those light bulbs in just a pattern alongside that loop. Whereas parallel circuits, they do a little different. So excuse me if this keeps coming up. I'll have to fix that later. Parallel circuits has at least two more branches that allows the current to move, like this. And you can see the split here, right? It's not the same as the one previous. And a lot of times these circuits will have more than one battery or one or more voltage difference or a voltage source. And so you'll see we'll have these splits right here, or these branches that the current can move through. So the good thing about this is that if one light bulb goes out, well, the electrons can bypass this area and they can go right to the next light bulb and continue it. And another thing is, if we have a parallel circuit, you can have different amounts of current going through the circuit depending on the amount of resistance at each part. So you might have one maybe light bulb here that's a resistance of 10 ohms, whereas this one's 15 ohms. So it just depends, and that's okay because we can have that variety now that we have a parallel circuit. And the advantage of this is that current continues to flow even when one branch goes out. And probably the best example of this would be if, any house now, any current home has these lights set up like this. I mean, imagine if you came home and one of your light bulbs burned out, let's say in your bedroom, and then the whole rest of the house, the lights just went out, right? I mean, how inconvenient would that be? And not even just a light bulb, but imagine if a refrigerator or any kind of resistor, anything taking in electrons, what if one thing went out and it caused the entire house to just go out as well, right? So luckily for us, our houses, our homes, and pretty much any place that we go, we'll use parallel circuits because we don't want to have to worry about if one goes out, the whole current or the whole circuit, will go out. So parallel circuits are a lot more compatible and flexible with our kind of day-to-day technology usage. Now, when we draw circuits, we can do that, and there's different symbols that we can use to represent different things. So a lot of times, if we want to show just a light bulb, and we know a light bulb is a resistor or something that opposes electrons, we will typically draw a light bulb in its own symbol, so we know exactly what we're dealing with. However, if we're talking about an appliance, something like a refrigerator or stove or whatever, anything that uses electrons, a lot of times we'll denote that with this hill or M-shaped symbol, and that's will represent a resistor as well. Batteries, they'll be represented with these lines, these off kind of smaller lines on in between and longer lines on the bottom. And then if we just have a conductor or the wire, the thing that allows the electrons to move, it's just denoted as these lines that we've seen already. Okay, and the last thing that we're going to talk about is just to see how you could draw a parallel and a series circuit using just basic drawing skills. Obviously, this is not something that I think even I could do. I could pull this one off. So here again, here's a resistor, here's another resistor, and here's a battery source of voltage, right? Now it's a lot easier for us to draw these than to have to draw out, a really complex battery, a really complex light bulb, maybe, draw a stove. We can represent these things with just these basic symbols. And you can see here how series still works with this. It's simple. It's a simple circuit. A simple series circuit. You don't have to have any branches or anything for a series. It's just one loop. Whereas parallel, they have two branches, right? And if one goes out, let's say this light bulb goes out, this light bulb would still work. So what I want you guys to do, and this will be our last thing for today, is I want you to draw both of these and make sure you label each one, this series and this parallel, so that if you were asked again to draw one, or you were given certain information about a circuit, you could draw it based off of the information given. Okay, that's all for today on circuits. Thank you guys.